Hello, hi. I hope you're doing well. Welcome to my tutorial. We're going to talk about how to convert a SparkSL to patch editor. And it's not more about conversion, but since I took a poll out and where I found out that a lot of people are not very familiar with the SparkSL, so they would like to go with patches for something like a shader, but I would like to teach both of the comparison, so you could use both of the knowledge. If you want to go with SparkSL, that's totally okay. If you want to go with patches, that's totally okay as well. And I think we could do most of the things in patches as well, except some of the for loops or those things. So we're gonna avoid those while we do this tutorial. But I think even if you don't use for loops, because they're anyway very expensive to work with, we could just use other methods, other tricks and techs to kind of achieve what we want using patches as well. I'm going to show you the expectation from today's tutorial. This is camera texture. We're going to make this Truchet effect. Truchet is just that we kind of divide the screen into a couple of grids and pass our camera texture, and then we modify that grid to be like to run with time and keep running with time, make these random loops. So this is very much inclined towards modifying your UVs and get a new UVs, get a circle UV, get a grid UV, and then we'll just use those UVs to make this effect. Okay, so I'm gonna start with a little bit of basics of what does it mean to have UVs in your patches and what does it mean to have your UVs in the SparkSL. Alright, let's start then. Okay, here we're starting with a blank project, and this blank project has nothing into it. We don't even need the lights, so we can delete these. We would like to add a rectangle where we're gonna print a Truchet, so we can call it Truchet rect, and it should be quite big enough to hold our Truchet, and give it a material and Truchet. And we'll just bring it in here so we can process with it, and then we'll create a shader code asset which we'll use to compare what we're gonna make anyway. So alright, I think this is the default shader code that you get if you import. Just create a new shader code asset, and this asset gives you a star, and you can modify these, and this gives you a star because of the SDF used in there, and there are some variables where what kind of color you want and what kind of color 2 you want, and then this kind of like a blend versus gradient is going from this color to the color number 2. If you put it at 0, this is just going to be gradient, because we kind of told our code to like don't care about the SDF, because we're taking that floor and we're not accounting for SDF. This is pretty much similar to having a gradient in your patch, which is a horizontal gradient, and just a gradient step which has like a first color as this color, first color as this color, and the second color as this color. And if I give that output to my Truchet, my material, I'm gonna get the same thing, and I can shift where do I want to start my gradient. If I want to start my gradient at 0.5, then whatever is before the 0.5 is considered as negative number and will print only black, and this is going to be entirely white. To visualize this gradient, you could also visualize the gradient where wherever I have the black, it's fully transparent. So this area is fully transparent, while this area here has like a black is fading out to white, and that white is starting in the half of it, and white is going completely white here. We're gonna use this a lot, these gradients and this conversion of gradient, shifting the gradient from 0.5 and whatever comes before it, like negative numbers, just make it black. So we're going to use this technique a lot. So just wanted to put it out there. To start with, this is just for an example. I'm going to just delete it and I should a code asset. Right now, I'm just going to delete everything because we don't really need anything from the shader asset. And if you compile it, it's just going to give you an error because there's nothing returning from it. Alright, we're going to start with everything completely black since we have to make now we have to make a vector4 function, for example, because we're going to return a texture to it. So this vector4 main function has to return something which is a vector4, something vector4. So we gonna say that let's return a completely black texture. So I give it a color like vector3 color, and that is my vector3 black. And every time you use a number in SparkSL, always make it like a floating number, and then I'm gonna declare a vector4 which is my output texture, and this output texture should be vector4, which takes the color and also gives the alpha is 1. And if I now return the output texture, this should be giving me a completely black texture. And in patches, if you want to kind of duplicate what we did here, so this is equivalent to is that this is equivalent to giving a vector3 value, which is, let's say, 0, 0, 0, because, and then I'm going to create a sender to it, and I'm going to call it like a color, so that it's easier to put things here and there. And this, as you can see, that this is the vector3 color, and this vector3 is this should be packed with now if I pack it with, when you pack a 3 vector like a vector2, so this is vector3 coming and this is a vector4, so this is like this pack is actually representing 4 values. So if I give this to my Truchet, this should give me the black color, but my alpha is right now 0. If I make it 1, this will be like the same thing. So right now we are the very similar setup that we have in SparkSL, and so this is just like a very basic setup that you want to do in the patches before like converting something. And SparkSL just create a main function and then try to just output a color, and then from there like we'll build upon it. Okay, this is the basic setup. Let's talk about the Truchet effect, like what is it, and how do we approach to do it, how to approach to make it. Okay, so the Truchet effect is a very simple example how our screen is kind of divided. This is our main screen, and what we're gonna do is like we're gonna divide this into a couple of grids. So we'll just divide this screen into a couple of grids, and we'll try to make a texture into one of the grids, like possibly in the center. And when we make this texture, we will like to fill all of the grids with the same texture like this. And when we do that, you see that they start to make continuous lines because we fill them with the same pattern. And pardon my drawing, but this is not it. But then we will like to shift these textures randomly, like this one too, maybe like this. So our new grids will have these lines, like let's say this is a grid and we fill them, some of them like this, and some of them we sort of flipped like this. So some lines are like that and other lines are still like this. So this is how we're gonna make this effect. This is the main approach to make these patterns. Some of them can just give you a very random pattern, and then we'll kind of maybe curve these lines to make it a very smooth effect. Okay, I hope that's clear. Earlier we had our black textures ready for us. And then the next thing we want to do is to kind of divide this into grids. But first, do that's obviously we would need our UVs to make it happen for us. So first, how do we decide? How do we know the UVs in SparkSL? Because in the patch editor, it's very simple. We could just go to vertex attribute, and this vertex attribute is going to give all the vertices to us, and we would just want the texture coordinates for now. And I'm just going to keep this in the sides because this is the same thing. And this is my UV, which is like the entire screen UV, but we'll modify this obviously. How do I kind of use this UV to make something here? What I can do is I can change my color of this output to something. Let's say I'm gonna use a pack. So basically this is gonna just give me two values. So let's say that can define my R and G, and that means I just need a vector 3 value from this, and then the blue can be 0. And if I give this here and use this output, not the shaded one, and this should give me a combination, all the colors from red, combinations of red and green. So based on the pixel coordinates, like this pixel coordinate, it's 0, 0, 0, 0, 0. So 0, 0, when I give 0, 0, 0, it's gonna be like a black texture. And when I increase my coordinates, if I go here, my x coordinate becomes 1, my y is still 0. So this is going towards red because I'll have mostly the red color. Because here at this point, I just have like my x is 1 because we're going from 0 to 1. My x is 1 and this x is 1, my g is 0, so it's completely red. Similarly, my x is 0 here and my y is 1 here. So this becomes my 0, 1, 0, which is like RGB. If my G is 1, then it is going to be completely green. So this is why this is printing that mixture, like for a point like this is a 5.5. So it's a mixture of red and green, and then my blue is anyway 0. We could do it differently as well. Let's say I don't want red color in my end, and I just want to change my green and blue texture. Then we have like a combination of green and blue similarly. But this is like I'm gonna use this. So this was my UV. That my UV is changing my things for me now. So that's good that we have the UV now. Let's do the same thing here. How do we invite the UVs here? So there's also we call a vector 2. UV is a vector 2 function because it gives you x and y. So we say like vector 2 UV should be std and std and to get vertex text attribute text coordinates, and then this should give me my UVs. And obviously we are kind of using everything on a fragment shader, but let's say it's better to put it maybe later, but this works as well. So now if I take my UVs and change my this vector3 color, which was 0, 0, 0 earlier. If I take my uv.rg values, or we could also say xy values, but rg would make more sense just to visualize it, and my blue stays at 0, and so now this color is going to my output texture, and they should give me the same result. So earlier we were black here, now we change it and we are at the same result. All right, and similarly we could also modify it to, let's say I just want r, and that means my x and y both I'm doing r's, then it's gonna be, you know, like the values are going to be the red for green, red for red, and also red for green. So that's gonna make it like a yellowish texture. Also we could do this like my red becomes 0, but my vector 2 and like my g and b value becomes uv.rg, then it's gonna give you the blue and green, the same thing that we had earlier. For now, I'm just gonna keep it to, again, uv.rg, 0, and then this will give me this color again, which is alright for me to have it like that. But again, we wanted to divide it into grids. Right now it's just like one simple rectangle. We would like to divide it, this UV, so basically this is our UVs, and I'm just gonna create a sender to this, like we created a variable there. So this is my UV, all right, that's a vector2 value, just to. Now how do I divide this UV into blocks? So to do that, I think I'm just gonna fragment. Now I'm gonna fragment stage. So because we're running this code, the fragment stage, and so right now this is our vertex attribute, but when we go to the fragment, we wanna kind of divide it into like based on a grid, like how many of this can be returned as itself. So let's say we take like a 2 section, like we divide this screen into like a 2 sections in X or 2 sections in Y. So how do we do that? So I'm just gonna have basically to do that as a fract. So we use a fract. We don't have a fract function in SparkSL in patch editor, but we do have in SparkSL. So what we're gonna do is we're gonna fract it. We're gonna fract this. For fract, let me share like what is a fract and what is a modulo, and what is the difference between these. Okay, so the difference between the modulo and the fract is very minor. So the modulo is always between x and y, and fract of a single number gives like subtracting the floor of same number from the same number. When you take a modulo of x and y is 1, then putting the y as 1, we will get x minus floor of x only. So when the modulo is taken with respect to number 1, the modulo and the fract, they deliver the same number, same result. So this is the main difference. So if your y is 1, then you could also use modulo, else you can create your fract function in patches as well. Now that we understand what is fract, we could make a fract, to be honest, very easily. So fract is a number subtracted by the number floors of itself. So if I have a number and that number is subtracted by the floor of the same number, then this output value is my fraction of that number. So if I have 1.5, so this should give me 0.55. This should be my fract. So I can just group it and call it fract because we don't have a fract function. So we will use the fract here. Alright, so I'm going to delete these and take a fract of of my UVs. Well, right now I have like we have this entire screen, and we don't know like how much fraction, like we have the 1, so the fraction is actually 0 because this is rendering as just one screen, one UV, you can say. But I'm gonna multiply it now to make it like couple of things. So like instead of 1, if I give you a 2, then it's gonna be different now. So I divided this to 2 in X and 2 in Y because we are multiplying a vector 2 with a number 2 in both directions. But when we had 1 here and 1 here, we had 1 here and 1 here, then it was the same thing. But if you do 2 here, then it's going to divide the x-axis into 2 parts. If you did 3, it's going to divide it in 3 parts. And similarly, if you do that, it's also going to do the same thing. I read this question somewhere in community, like how to create like a LUT, which is the natural LUT, which is like, let's say 1x16. So this is the way to do it. This is in the Y, but maybe 16:1. This probably is to do it. Probably you have to change the colors the way you would maybe XYX or something like that, and that should maybe give you some LUT colors as well. So, but for now, we're just gonna keep the numbers uniform. So I'm just, either you can put like same number here, or just keep a number that you multiply with, and just keep it to 5 or maybe 3 for now, just to understand and look at it a bit better. So every grid starts with the same thing. So earlier my 0 to 1 was like this, and 0 to 1 were like this. Now I have 0 to 1 here, and then 0 to 1, and then 0 to 1, and 0 to 1, again 0 to 1, and 0 to 1. So this is repeating everywhere. Let's do the same thing in the shader code asset, and to do that, it's very easy. What I did was, you have UVs here, so my UV, I'm changing my UV to become like a fract of UV, and this shouldn't change anything because we haven't multiplied it with some number. Okay, let's try and multiply it with a number which is like UV equals to, I'm going to multiply it with, let's say, a number 3, and this should give us the same results. Sorry, 3 has to be float number, and what's happening, we have to kind of go to fragment stage to do that. So I use fragment, and that's it. In like when you have like multiple attributes or functions to use from std namespace, you may have to like write it again and again. So you can avoid that. You could just say like, hey, I'm using namespace std, and then that sums up to not put it again and again, and then just like it's gonna be like, okay. Now we have the same result as we had in the patches. For just to recap, what we did, we took the UVs, we said like, okay, go to the fragment stage, and we divided that to have like a 3 sections into the X and 3 sections to Y. So all of them are going from 0 to 1, 0 to 1, 0 to 1, and we're still taking our UVs XY coordinate and then using that as a color, just for test, but just to visualize things better. Now we have it. Now next thing that we want to do is to create lines. Let's create some beautiful lines at the border, like grid lines at the border, so that we can visualize our shapes better as we go. To create a border, what we can do is my borders should have like lines. So how do I get to the border? How do I know that I'm at the border? Is because right now I'm at 0, here is 0, and this is the 1. So to create a line close to the border, we have to go to the 1. And actually, before we go there, we can kind of shift our UVs to start from the center, because right now our center is 0, 0 here. And it would be convenient if my center is here, because then going to the border this side and going to the border this side, we could just use like a 0 to 0.5 and 0 to minus 0.5. So we could use the same function to do that. And right now, it's just like I have to write something for 1 and I have to write something for 0. And those values are like that. But if I am here, I can approach these coordinates by using like just one function. So to shift it, shift my UVs a bit into the center, what I gotta do is that right now you're going from 0 to 1, so my UV has to be shifted to the center. So if I can subtract minus 0.5 from it, I will possibly shift my center somewhere else. And you see that my center has been shifted here, and before this everything is black. 0 to this 0.5 is black, but and 0.5 to this is my center, and then it's grayed out here because everything is considering as black. But we still have the texture here, but that's okay. We got the things right. But if you can invert it, if you like, just maybe I'll say that my uv dot y should be equal to 1 minus my uv dot y, which means that whatever right now the setup is, like my greens would be up now, my red would be right there where it is. So now we have like a uniformly, I can see that like this is, if this is minus 0.5 to 0.5, but since this is positive x, this is all positive, so I can say that we're printing colors here because this is positive x, but y is negative in here and x is also negative in here. So from this point below, everything becomes black. Everything is here is black. But here my y was positive, my x was negative, but still I have something. So that's why the print color is printing. But in here, everything is black. So we can safely assume that now we're at center and minus 0.5 to 0.5. So yeah, I would like to do that in my patches as well. So my patches are still at having my center at 0, 0, and that this green is at the bottom. So first thing we can do is change the greens of the converted UVs, which is, this is my converted UV after fact, and I'm gonna unpack it in a vector 2 and take this x is okay. I'm gonna pack it again to vector 2, and this I'm going to multiply, so I'm going to subtract from 1, and here we don't need the floating values, but in the SparkSL we do. This considers them like, just treats them like 1.0 already. And if we do that, so now my new UV becomes this, so my green is up. If I don't do this, then I have this, and this is just inverted. Okay, I want to shift all the UVs to the center. So whatever UVs I had, just subtract 0.5 from them, and then that becomes my new UV. So I have this similar texture now. So to be able to work with it, we will just keep these UVs somewhere else now. Just put it because we can always use these UVs to make some changes in here. And so this is our current setup. They both look same. They both gives us the same output. Now the important part is to create the outline. To create the outline, and this is 0 and this is minus 0.5 and this is 0.5. So if I want to create a line, I'll probably create a line where somewhere is like 4.8 to 5.5. so 4.8 to 0.5, if I print something, and similarly from my like minus 0.48 to, this is, I'm talking about my x, that should give me a line. So to do that, let's understand this in the SparkSL first. So I'm just going to connect it here. In SparkSL, what we want is to have, if my color, I'm going to say that if my UV dot x is greater than, let's say, 0.48, then you know, my color right now is this, but if this happens, then my color should be something else. My color should become like a vector 3 value, which is what color of line we want. Let's say we want white color for now, and if you do that and save it, we see that we got that light because my UV is after 0.48, and then that means that if I make it like 0.4, you'll see that the width of this will become larger because we started from like that. And if you start UV is greater than 0, then it will print all the like a very thick line. All right, so to create a dot, it will create a very thick line from starting from 0.5 to here. And but we don't want this thick line, we just wanted to create a border, so we'll just use 4 for now, and this will give us that that line at the edges. And also if I do the same thing for y, uv.y, that should give me the, like, from 0, and this is my 0.5. If I 0 to 0.5, if I want a line here, then I should probably just, you know, go for 0.48 again. And if I do that, I will get those lines on the upper axis. And but I want both the lines. I want these lines and I want those lines as well. So what I'm going to do is I'm going to say like or that my UV is greater than 0.48, and also my UV.x is also greater than 0.48. Actually, for the readability, we first modify the x and like y. So this should happen for both of these colors, and maybe it's going way beyond the screen. So all right, so this should give me the grid lines to everywhere. Yeah, makes sense. You can choose a different color, maybe let me some color which is not green and red so that they're always visible. So we can go for maybe a color like this. So this is almost it's almost 1 1. So I'm just gonna use a 1 here, and I'm gonna use a 1 here. But of course we have to use a floating number, and this should give me a good bright blue color. So I have the lines. I have the my color is printing where I defined it to be. So everywhere else the color would be defined by UVs, but if I'm in this region, then my color should be this color, and then that's pretty much it. So we have this ready, and but our patches are still unaware of this magic, and so we're gonna do that. We're gonna make it happen. And to do that in patches, so challenging part actually, because if you use if then else, and then we say like, okay, if my uv.x is something like, I'm gonna swizzle it to x, and if I say if condition should be that So if I say like greater than, so I can't use that because it says like it is a scalar operator, and what we're passing it to like a shader values. So we can't use this if and else and these Boolean patches. So the way to do that is we use a smooth step, and we say that if you're greater than 0.48, and my also maximum edge is 0.48, but you could put 0.5, but it's gonna work because it's gonna work anyway. Let's try it out, and if this becomes my condition, then multiply with all such UVs with a color which is vector 3 color and has like a blue color. So if we do that, now my color should be, so this is my UV and my color is coming from here. So I'm gonna probably add these two because I want the color and I also want my lines, which I'm printing right now for in the X direction, and this should give me a white, like a color line here, and it did. If you use 0.5, that's also very fine. I think that's the right way to do it because we're going from 0.48 to 0.5, and then you can always increase the width. But if I just keep it to 0.48 and this also 0.48, it's going to be sharper. If I use 0.4 and also 0.4 here, it's going to be very sharp like that. So 0.48 and 0.48 is my at the line is where am I. So this is my new color, and the same thing I want for my X, my Y as well. So this multiplication is going to be same anyway. I'm going to use the same things in here. So I'm going to now swizzle the Y, take the Y coordinate of this guy, and same conditions, but I'm going to add these two and then multiply with the color that I have. So I'm going to get the same thing that I got in the SparkSL code. So now I have the same result. We could call it like lines and then probably just add it like that. So I'm gonna use a sender and call it like grid lines, and we'll use it here and then just take it somewhere else. So basically this is my grid lines, right? Okay, we are also done with this part, so I'm just gonna take it somewhere else and call it my grid lines, coming down, and call it my grid lines. This is my grids, and this is my UV. I'm just gonna, it's better too because our project is gonna get larger and larger, so we will just use them like sophisticated, put them like, so right now what I have is I have my color and I have my grid lines, and I'm adding those textures to packet in a vector 4, which gives me a Truchet materials texture. The both are the same thing. We got the line, we got the but okay, lines are okay. We don't want the border. Borders are just to kind of visualize like which box are we working in. Now we're gonna work inside the box. Now our goal is to make a line, like we can draw a pattern. Like the simplest pattern is a line. We could draw a vertical line, we could draw like a horizontal line, but we'll go with like a diagonal line. Okay, so we're gonna take our color values and we're gonna add something to it, like maybe uv.x, because now we go towards the from UV from 0 to 0.5, then it should increasingly give us some texture. Like maybe initially we're adding almost no values because we're close to 0, and then we're close to 0.5. So this is where we're gonna have some impact, which is like at the boundaries, you know. At the boundaries there should be some changes, but in the at the center there should not be any changes. If I save this, I see that okay, it has amplified the colors here, because I think it is kind of so to see it better, just remove these colors because we don't need them. We just wanted to visualize it earlier. What we need here is maybe this entire thing can be just completely black. So now I will see that what it's actually doing is that we are starting from 0. It was nothing, and then we added some values, and when it reaches 0.5, it is kind of giving me those values. And similarly, we could do this for y as well, and this will give me that for the y, and for the y and for the x. And if I add these values, what I should have is like just diagonal, you can guess. So I'm gonna do that uv.x and plus, so this should give me the kind of diagonal, and before that everything is going to be 0. Because now I'm adding the values, like I'm kind of, earlier I was going like this now, and then I'm going like this, but now I'm shifting like this, like I'm adding something, then I'm adding something, and then this is my maximum value that I can add. Okay, so we're gonna maybe put this in a new variable, because this is a vector2 thing. Now we're gonna call it like a layer, maybe we added some layer, which is the same thing, and we put it here, and then just call a layer here, so that this should give us vector uv.x and uv.y. That this is not a vector, this is a float number. Sorry about that. This is a float number, and then this should give us successful compilation. Yep. We do this in patches first. In the patches right now, my colors are still taken from here. So if I remove this and make it like a vector3, then my colors are black, and I have the outlines. And what I want to do is I want to add my UVs from X and Y. Actually, let's call it something like this. It's like a modified UV. So I'm gonna call it new UV, and then this is a new UV now. And we're gonna do the same thing here, because we might need these UVs somewhere else, and then we're not left with that. So my new UVs are actually this, after converting them, after doing the fract and then subtracting. So I'm gonna call the vector2 and new UV. It's unrelated what we do here and what we do here, just to keep the similarity between the variables and the values. We're gonna use the similar things. So this new UV should have I'm gonna just unpack it quickly to access its X and Y coordinates. And if I do that, it's my X and my Y. I'm gonna create a sender for this, which is my UV new X, and similarly I'm gonna have another one, which is my new UV Y, and I have to add these values. So I'm gonna create a receiver for both of these and add them together. And when I do, this addition should be added to my color values. This is my color value, and so if I add this to here and then pass it here, I have the diagonals, right? You could obviously, you could also try adding just the X and you'll see that the X, and you can try adding just the Y and you can see the Y, and you can try adding this, and this could be like a diagonal. Now obviously I would I don't want that, I want a line. And how do I have a line is that when we did this, we draw these grid lines, what we did was that, okay, we started from point 4 in our smooth step, and from point 4 to 4 we had this that line. So in here, I think, where do we want our line? I want our line to be at the diagonal. Okay, so that means that if I'm at the center, I can go a little bit in the side from the center in right direction, and also in the left direction. That means if I use a smooth step just before passing it to the color, if I use a smooth step, and the smooth step is going from 0.01, which is very close to 0, to minus 0.01, then it should give me a line. So this gives us like a very sharp edges, like from but I want a line, not the sharp edges. But it's happening because we're defining it too. Let's just invert them for now, and if you invert them, you'll see that so basically we're telling this that this is my -1, and if I go like -0.2, then it's going to be like a little bigger. So I'm telling it to that wherever I have negative values, just print black, and wherever I have positive values, print white. But to do that in the line, like basically this black color in the bottom is not really useful for me. Maybe I want to get rid of that. So initially we had this. Okay, so we were just printing some things up on the upper quadrant, but let's say we want to do that below as well. So how do I mirror this? So because the negative values are black, so I don't want any negative values anymore. That means if I just take a positive of whatever negative values I'm getting, I should get the same texture that I'm getting on the up. So I'll take an absolute of this, and if I put it directly there, then it gives me like a very similar texture at the bottom and similar texture at the top as well. Now if I take this smooth step, that should definitely give me a line. All right, that just gave me a line. But we want white color lines, so rather than this color line, we could do like subtract it from maybe 1, and then you can get those like this. But again, maybe don't subtract it, just revert this like 0.01 and minus 0.01, and then you should get it as well. So we've got the diagonal line, and we can kind of maybe multiply it by some number to just make it a little sharper, like visible. So maybe 1.5 is okay. Okay, so this is what we did. We created we added the UVs and X. We were initially at here, and then we took the X and Y and we added them to create a diagonal, the diagonal gradient. And then we wanted the same gradient which was at the top, at the bottom as well. So we took an absolute, which gave us like the mirror of whatever was up. And we we cut the line at the diagonal by saying that wherever I have like point from 0 to here and 0 to here, from point 0.1 from the origin and minus 0.01 from the origin, just cut the line, just take the smooth step to cut the line, so I drew that line here, and then we have it. So this is fairly I think. And how do we kind of like, do we have this in the, how do we control the length of it? Like how do we make it like a wider line? So if you remember from these lines, these lines, if I was increasing, like if I go from 0.4 to 0.4 or 0.3, that will make like a wider line, you know, like a in both ways. If I make like a 0.4, so that if I'm increasing the edges, like where I'm starting, I'm kind of getting a wider line. That means if I do the same thing here, and from the absolute, like after getting the absolute, if I subtract, so here also, like this was my the entire, like this was my this black texture in the middle, and if I have subtracted something from here, let's say, then it would have definitely become a like a bigger, like how much do you want to do that? So let's say we do that 0.1, and then if we now take a smooth step, and this will definitely give us like a wider line. So this can be controlled by this, so we can call this variable like a, maybe create a sender, which is my width of the line, width of pattern. All right, that's what we're gonna be. This is, and I'm gonna put like 0.1 for now, and make a receiver and feed it here. So if you want a recap of something, this is pretty easy. So whatever pattern that I printed, so before just passing to the smooth step, I made sure that my length is bigger, that I'm going from 0 to higher coordinates now. All right, so yeah, let's do this in the Truchet. And in the Truchet, where are we? We. In the Truchet, I'm not sure what made it like that. Let's find out. So, because we changed our name of the UV, so that's my fract UV. So I have to change, where I'm using UVs, I have to change like a new UV, and new UV dot X, new UV dot Y. That should fix everything for us. Yeah. Now we have the color, which is the layer. This layer is addition of those, and what I did was I took an absolute of those. Absolute is a function, built-in function in SparkSL as well. So if I take an absolute, this is gonna invert this. It's gonna invert this to there. And if I now take a smooth step of this layer, between minus 0.01 to 0.01, comma, this should give me a very nice cutted line. And want it the other way, so negative and the negative. Okay. Also, I want to be like a little brighter, so I'm just going to multiply it by 1.5. This is like a brighter line. You could use a high number as well. And what else did we do? Do we have the same output? No, we also have the length changed. So change the length, what we did was like the layer, we increased this layer by a number, so which we can call a width. So we have to declare a vector, actually a float number, width should be at 0.01. Cool. So we have a nice cutted line here as well now. Now we can actually get rid of these things. Like if you do this, then you'll just won't see the grids, just lines, you know. So we could also do that in patches, and a way to do in patches is to kind of, let's say don't want to give this a smooth step at all. And if I do that, I'm just gonna get the lines, nothing else. It's probably something that we're adding and not like, yeah. So if I don't use this at all, maybe our width is too much. 0.01 is what we're looking for. But I understand 0.05 is a better visualization, and then we're gonna change that as well. So for now, I want the grids, but to remove the grids is that I wanted to show these. There's a problem in this. The problem is that we have a, like, the lines are cut at the end, but they end when they meet to the corner of the last vertices, and the same for them. They kind of end up making a pattern. It's not like a continuous line. So how do we fix that? If we have an angle, so if the line shifts, this angle is going to be like a flatter. So one way to fix it is to create like we shift these lines to, like, maybe let me bring those back. Like, instead of going from this point to this point, because we're going negative, like, because this is completely negative at some point, so it won't print any values at the end. So what we do is that we shift it to maybe center of these lines. Like, instead of going from here, I can just shift this to go from here to here. And if I do that, that would be great. In here, like, so to visualize it better, I'm just gonna give directly here. So we were, before drawing the absolute, if my gradient could be instead of at the center, if my gradient could be at the center of this line, so maybe not from 0.5 to minus 0.5, instead 0.05 to 0.5.0 0.5. So I just have to subtract. Maybe a number to this, which could be, and then I'll take this subtract, and I'll see that what the subtraction gives me. So right now I'm not subtracting anything. If I'm moving up. If I move it up like all the way, this is probably gonna give me that what I need. And if I passed it to absolute, and now if I take this outward, I think I have a line which is from the center of this to center of that. To one thing to note, that now we probably have gotten rid of our problems that we were having with that, because now we have like a flat this, and then if anything comes from the top onto it, we could just like fit on it, instead of like making a cone, an angle. Something can just fit on it, and if it's slant, something can fit on it. But if it's like a cone and if something fits on it, it's always going to create that artifact. So it's much better this way. And okay, I got these lines. I also want the same lines to be at the bottom as well. Like, okay, I have having those lines from 0.05, 0, but I want to also have the same line at the negative of it. That means I need an absolute, that's for sure, because I don't want to write another code to do the same thing. So which absolute would make it work? Okay, so I just what is my goal now is that I want this line to be like continuous, so we have that pattern, so like everything seems connected. All the UV seems connected, like, because we're gonna get rid of these grid lines anyway. So to do that, what I need is like another texture in here. And to get this another texture in here, I have to think in a way that every time I take an absolute, it converts the negative values into positive values. So if I want to print something in here, that means these are the UVs that I'm not printing right now. So if I take an absolute of this before subtracting, would that give me the result that I want. Let's try that. Yes, I will, because and to understand it better, like before we give it to the absolute, and initially we had this diagonal, like printing only diagonal things, and if you take an absolute of this the entire thing, then what we do is that we kind of, you know, do the same thing, but now we subtracted it. That means we shifted it up, you know, like we shifted this entire thing, and then hence our values are we're getting down there as well, and the up as well. So these are my lines. I think these are my lines that I'm getting. So as an absolute, we subtracted it from the width of it, and then we had a smooth step going from 0.1 to minus 0.1. We multiplied it and then gave it like a color. So this is like a pattern that I'm kind of adding to the color. So I'm going to just center and create a layer variable, and this layer variable is then being added to the black color which is in the back. Anyways, also when I do this, the shader, in shader we have to shift this. So what do we have? Until here, this is what we were getting. So we have to shift our we have to shift our x and y's there. So to shift our x and y's, what we gotta do is, this is the addition of the absolute, and then we have to shift this, so we can just subtract 0.5 from it. My UVs, they're gonna shift up, okay, and then I can take the absolute of my values, so that I just have the positive values. So I just added another absolute here, and this just gave me the line. So we're at the similar stage right now. Now, one thing to note is that I want randomcity right now. It's like everything is so uniform. If I have these lines and if I move them, it's a very common pattern, and then you could just, you know, use some simple patches to do that. But what I want is to simply change my new UV dot x and multiply it by -1. If I do that, this is gonna flip the lines. This is gonna 1.0. Excuse me. Where is the new UV? Okay. If I take my new UVs multiplied by -1, this is gonna flip the lines. So earlier I was going in this direction, now I'm going in this direction. What this tells me that we can do this for some lines in randomly. Like some lines can be like this, some line can be like this. So they make, you know, fall some sort of pattern. But to do that, it's just it's a tricky part, because now we're applying everything on all the UVs, like of this small rectangle, and then applying it everywhere. But to do that, we have to define an ID for every square, every rectangle. This should have an ID. So, and then if it has an ID, we will use the ID to identify that where are we right now. So once we define that ID, we will be able to flip the textures of each line. For example, if it is 180, then we can flip it to -180, and then they will be able to make some closed and open patterns, sometimes loops as well, and we will use those patterns to curve them later. So there will be even a better pattern. But to do that, it's a little bit of like a mathematical approach that we're gonna apply. We're gonna write a function to assign those IDs to every other grid box, and we're gonna do that in the next part of it. I hope we understood a bit today, and next time we're gonna do it a little quicker and faster, because it took a lot of time to kind of go through the basics as well. But now we know how to draw lines and how the smooth step works. Next time it's going to be like super easy, but this is going to be a super cool effect, because on whatever lines that we are making, we're going to make them move. We're going to write a hash function, and we're also going to pass a camera texture to each pixel of that line. So basically, whatever camera texture we're going to pass is going to rotate with it, zoom with it, and we could do many things. And we're just covering right now like a very basic pattern of like a square grid, but there are like 1700 types of grid that you can explore: hexagonal, octagonal, or dodecagonal. Like there are a couple of types of grids that you can explore, but this is pretty basic, just like a square. We're going to build upon it, but we're going to start from here. So I hope you get to learn something today. All right, cheers. See you in the next part.